Hello. Well, here we are again. Today we're going to be looking at section 4.7, complete the square. And this is going to be new stuff for sure. Let's go ahead and get our heading up here. 4.7, complete the square. Now, before I get into our formal notes, I want to give you a couple of examples to kind of run through why we're doing these things. A little bit of a preview, if you will. You don't have to write this down, but just pay attention here. Suppose you were asked to solve, and you were given a quadratic, x squared plus 4x plus 4 equals 9. Now, you might be tempted to subtract this 9 over and then try to factor it. Well, I tell you, you might run into some troubles there. It might work out nice. But I want to show you another way that you can do a problem like this. And the way I'm going to show you could be then used for all sorts of different problems. What you could do is notice that you've got a perfect square trinomial. A perfect square trinomial. Square root of 4 is 2, and the middle term works out nicely. So what you could do is you could rewrite this as x plus 2 squared equals 9. And then from there, you could solve this using square roots. Square root both sides, make sure to put plus or minus. You'd have x plus 2 equals plus or minus 3. Subtract the 2 over, and be careful in here. What you get is you got two answers. You're going to have 3 minus 2, and your other answer is going to be negative 3 minus 2. And so you'll get an answer of 1 and an answer of negative 5, which is the same thing you would get if you tried to factor it out. So what I just did was I solved a quadratic that had a b term in it using square roots, which is kind of revolutionary. So like I said, you don't have to write that one down, but I just wanted to show you where we're headed. Let's see. In case that didn't come across, let me just set up one more for you. X squared minus 12x plus 36 equals 32. This right here is a perfect square trinomial. You could rewrite it as x minus 6 squared, a binomial squared, equal to 32. Square root both sides, and work it out. Now this one doesn't square root nicely. It ends up being 4 square root 2. And then you'd have x minus 6 equals plus or minus 4 square root 2. And on this one, when you add the 6 over, they're not like terms. So you get to just write it as 6 plus or minus 4 square root 2. So anyway, there's some examples of where we are headed. Today, what we're going to learn to do is we're going to start to learn how to complete the square. So what I want you to do is I want you to look more closely at some of those perfect square trinomials. Look more closely at perfect square trinomials. And I gave you a couple of them just a second ago, but write these down. X squared plus 6x plus 9. That's a perfect square trinomial. X squared minus 2x plus 1. That's a perfect square trinomial. X squared plus 10x plus 25. That's a perfect square trinomial. And then I got a question for you. What's happening to the b term to get the C term. What's happening to the B to get C? It turns out there's a relationship here when you have perfect square trinomials between the B term and the C term. Now where we're heading with this is we're going to be able to write a perfect square trinomial in any problem. And when you're able to write a perfect square trinomial in any quadratic, then you're going to be able to solve any quadratic by using square roots, which is pretty amazing. So, but the key to this is we got to figure out the relationship. We're going to be given B terms, and we're going to be asked to find out what the C term would be to complete the square, to make it a perfect square trinomial. So take a look. We've got a 6 here, we've got a 9. Try to think of some relationships of how you can go, some operations that can take you from a 6 to a 9. We've got a -2 and we've got a 1. Try to think of some operations that would take you from -2 to 1. We've got a 10 and a 25. Try to think of some operations that would take you from 10 to 25. And I got a hint for you. It's 2 steps. It's 2 operations. 2 operations. Think about it for a little bit. Maybe pause the video for a second and think about what are 2 operations that would get you from 6 to 9, -2 to 1, 10 to 25. Pause it for a little bit. All right, so it turns out that one way to write this of what's happening to go from B to C is to write it this way. C comes from taking B, dividing it by 2, and then taking that result and doing what? Squaring it. Half of 6 is 3, square it, you get 9. Half of -2 is -1, square it, you get +1. Half of 10 is 5, square it, you get 25. So this right here, this formula, C equals B over 2 squared, is the secret to completing the square. Tell you what, go ahead and get that written down. I'm going to erase it so I have room on the video here to do all this. We're going to do a few examples with this. Now I got to tell you, this is the first steps of learning completing the square. We're going to apply this to some problems, kind of like I did at the beginning of class or beginning of the video later on. But right now we're just kind of learning how to do this. I've got 4 examples for you. 4 examples for you. And the instructions are: find the constant so the trinomial is a perfect square. Find the constant so the trinomial is a perfect square. And then the next set of instructions is to go ahead and factor it, which, because you've made it a perfect square, is going to be really slick and easy to do. So let me show you what we're talking about. Our first example is x squared plus 2x plus c. We want to know what c value makes this a perfect square, and this is called completing the square. What c value makes this a perfect square trinomial? Well, what we're going to do is we're going to use that formula that we just developed. Our c value for completing the square is going to be equal to our b value divided by 2 and then square it. And in this case, our b value is 2. 2 divided by 2 is 1. Square it, you get 1. So then write out your new perfect square trinomial and then factor it. Well, class, perfect square trinomial always ends up being a binomial squared, and you're done, and you're done. So use the formula to complete the square, make it a perfect square trinomial. Once you have it as a perfect square trinomial, square root of this, square root of that, same sign as your b term, write it as squared, and you're done factoring. Okay, let's try another one. X squared minus 12x plus c. Well, c is equal to negative 12 over 2 squared. Negative 12 over 2 is negative 6 squared. We get positive 36. Rewrite it as x squared minus 12x plus 36. We've completed the square. Go straight to your factored form. X minus 6 squared. Try another one. Keep going here. X squared minus 8x plus c. C is equal to negative 8 divided by 2 squared, which is, that'd be negative 4 squared is 16. Rewrite it as a perfect square trinomial, and then factor it. And then one more. So far, these have been pretty pleasant. They've all looked nice. No fractions left in there. Let's do one more, a bit of a challenge here. Let's do one more, see how you feel about it. Same instructions, x squared plus 1/3 x plus c. All right, when you actually start completing the square of actual equations, actual quadratic equations, and solving them, there's a good chance you'll have a fraction involved, okay? There's a good chance of that. So we need to be able to handle this okay. The formula goes, oops, let me switch colors. The formula goes c, to complete the trinomial, to complete the square, to find our c term, to make it a perfect square trinomial, we need to take 1/3 and divide it by 2, and then square it. Well, class, 1/3 divided by 2, you could do that in some of your nicer calculators. But what it actually does is you're going to be multiplying 1/3 by the reciprocal of 2. So it's actually going to be 1/3 times 1/2. And we get 1/6 squared. Now class, when you square a fraction, it's basically saying to multiply 1/6 times 1/6. But you could also think of, I can square the numerator, square the denominator, you get the same answer either way. But what we're going to end up with is a c value of 1/36. Now class, rewrite it as a perfect square trinomial. And even though this doesn't look like our typical factoring situation, we can rewrite this as the square of a binomial. We can factor this. And it's the same method. We just completed the square, so we can go straight to x. But then what's the square root of 1/36? Well, it was 1/6. You square root top and bottom. You're going to get 1/6. Our sign is positive. Slap a squared on it, and we're done. So now, a lot of you are going to find this really easy, and you're going to rush through this, but think about the steps, think about the process. We're going to be building on this process in the days and the lessons coming up, okay? Thanks so much. Oh, let me write this down. I forgot this on some of the other videos. Let's see, page 288, 3 through 9, all, and then 13 through 21, odd. I believe that's how I meant to set it up. If you're feeling overwhelmed and you want to do all odd, that should be fine. You just want to get a little bit of practice. Thanks so much.